Today we're going to start our probability unit, and the first concept is sample space. So sample space is the set of all possible outcomes of an experiment, which we think experiment, and sometimes we think, oh, like a science lab. An experiment could be anything like, let's flip a coin a bunch of times and see what happens, or let's spin a spinner, or even something like, let me put together different outfits, or let me, choose different items from different categories. Like an experiment is sort of just like a situation. So your sample space is all of the possible outcomes, all of the possible combinations of things that could happen. So our example is we're going to take a coin and toss it twice. A coin is tossed twice. We want to represent the sample space by making an organized list, a table, and a tree diagram. So these three different methods are all ways to write your sample space. So depending on the situation, depending on this experiment, you might choose a different method to represent your sample space, or we might tell you, you need to make a table, you need to make an organized list, you need to make a tree diagram, something like that. All right, so in an organized list, a coin is tossed twice. So what that means is the first coin could be land on heads, and then the second one would land on tails. That's one situation. The first coin could land on heads, and the second one could land on heads, because it doesn't change the odds of landing on heads or tails if you flip it over and over again. We could land on tails and then on heads, or we could land on tails and then on tails again. So that's my organized list. Tails, tails, heads, tails, heads, heads, tails, heads. So a table would be like a chart. Along the top, you would want to list the different options for the first coin. So the first coin could be heads or it could be tails. And then along the side, we're going to list the options, the outcomes for the second coin. So the second coin could land on heads or on tails. And then it's almost like a Punnett square, like what you did in biology. Our first outcome could be heads, heads. Heads first, heads second. Our second one would be heads, tails. Heads first, tails second. Then our next one would be tails, heads, and then tails and then heads, and then our last situation would be tails and then tails. And then the last way to represent the sample space is through a tree diagram. So our outcomes could be either heads or tails. So that's the first flip. It's either going to be heads or tails. Then let's say we land on heads. Then that second coin could land on heads or tails. Or let's say the first coin landed on tails, we flip it again, and the second coin could land on heads or tails. So this is like, if it lands on heads, it could land on heads. If it lands on heads first, it could land on heads second. If it lands on heads first, it could land on tails second. If it lands on tails first, it could land on heads second. Or if it lands on tails first, it could land on tails second. So it's kind of like different pathways for your outcomes. So all three of these are just different ways to write the same sample space. It's all of the different outcomes, like all the different combinations, all the ways that this could play out. That is what sample space is.